The hard disk is the primary mass storage device. It is also called a Winchester or HDD, hard disk drive. Because of its large capacity and speed, they primarily go for this and load data and programs from it. It consists of several metal plates coated with several magnetizable layers in an outer metal box that protects against mechanical damage, a red write head above each plate and electronic circuits. The drive rotates these disks at high speed, 3 to 8,000 RPM. The heads read or write digital data magnetically recorded on the disks, moving back and forth in each sector according to their position. Due to the air cushion created by the constant rotation, the heads do not touch the surface of the plates, so they are not. The write heads record digital magnetic signals on the surface of the disks using synchronous signals that determine the time of sampling, scheduled sequence check. The most commonly used digital signal recording mode, not only magnetic but also optical, is NRZI, no return to zero impulse, where 1 means the signal is reversed. Where a binary creates unidirectional magnetization, and where a 1-value signal is to be stored, it creates opposite direction magnetization. The sensing heads generate electrical pulses by sensing the resulting magnetic field, which are amplified and then modulated, transformed. In FM, frequency modulation, there is a synchronous pulse between each beats when the fixed value is 1. In the MFM, modified frequency modulated method, there is only a separate synchronous pulse between the beats if 0. Because the MFM method uses fewer pulses and the number of pulses that can be generated on the same surface is constant, it is more compact and efficient. Newer hard drives, such as EIDE and SCSI, use different versions of more complex but efficient RLL, run length limited, modulation, the essence of which is to make a binary sequence so that there are a specified number 0 between two ones. As the number of ones, pulses, is thus less, the capacity increases. The data is arranged on the disks in the form of concentric circles, tracks. The tracks that are physically below each other on the plates are called cylinders. Each track is divided into elementary data based on these sectors. Heads, tracks, and sectors are given, but the size of the sectors, expressed in bytes, is determined by the operating system. For DOS and Windows, this size is 500. The product of these four values gives the storage capacity of the hard disk, number of heads times number of tracks times number of sectors times sector size, in bytes. The data is located on the hard disk in the form of a dataset, in files of different formats. Depending on the operating system, files and directories, subdirectories, have a name that specifies the size of the dataset in bytes, a date that indicates when it was created, an attribute, property, with which we can, among other things, protect its access and deletion. In order for the files to be written to the hard disk, they must be prepared. After setting the location and type of the hard disk in the BIOS, the first step is to deep format, which creates a structure of tracks and sectors on the surface of the disks, excluding faulty sectors. This step is done by the manufacturers during production. In the second step, you need to partition, create a hard disk space utilization table, FAT for DOS Windows 95/98, NTSC for Windows NT, and specify whether to use either as a whole or for multiple logical drives. Managed by the operating system, up to 2.1 GB for FAT, virtually any size for FAT32 and NTSC, and configure the active partition. For DOS and Windows, issue the FD. The partitions must be formatted with the format command on DOS and Windows to create a hierarchical, tree-structured directory structure. The files are always located in either directories and subdirectories or in the main directory. This operation reduces You can also format partitions with the S switch on the format command in DOS and Windows, in which case the necessary system files are copied to the first sector, the boot sector, and the root directory immediately after formatting. To boot, you must specify the boot order of the drives in the BIOS. You can only boot from the primary hard disk, only from as technology advances. Previously 5.25 inches, now only 3.5 inches, notebooks, where small size is very important, produce drives with 2-inch, even smaller, disk widths. Different types of hard disks connect to your computer with different controllers. Old MFM hard disks work with MFM procedure. They are 5.25 inches in size. MFM controllers are control cards that plug into an 8-bit ISA slot and handle 2 units. The hard drive has a power cord, +5 and +12 volts, a ground, a data cable, and a control cable connector. It communicates with the control card via the data line and the control cable. If the control card handles 2 hard disks, one must be configured to 1 and the other to 2 for addressing access. The speed of the is approx. 1000 to 2000 RPM. Their data transfer rate, i.e. the number of bytes of data transferred between the controller and the drive in 1 second, is approx. 500 to 625 kbps. Their access time, i.e. the time it takes for the drive to find a specific piece of data on disks, 28 to 60 milliseconds. Their capacity is 10 to 80 MB. 3.5-inch hard drives were previously connected to the motherboard via an IDE, integrated device electronic control card that can be inserted into an ISA slot, but now an enhanced IDE controller is integrated into each. The old control cards include one 34-pin floppy and one 40-pin Winchester connector that handles 2 drives. The connector of the controller and the hard disk must be connected with an IDE cable. One cable has one primary, hard, and one secondary, slave, hard disk slot. IDE controllers handle up to 16 head. The newer IDE, enhanced IDE, controllers include one floppy and 2 Winchester connectors, handling a total of 2 disks and 4 hard disks. With Mode 3PO and wider DMA management, it allows data transfer rates of 13.3 Mbps, and for hard drives that support LBA, logical block addressing, mode, the max, it also handles 255-head hard drives. Another innovation of IDE is that instead of Winchesters, hard drives can be connected to other drives with the same interface, EXE reader and writer. If they are familiar with the extended IDE instruction set, they must work with the atop. For the drives to work properly, in the case of an IDE controller, the first hard drive must be set up as a master, the second as a slave in the BIOS, and by means of jumpers, small wires, on the small pins on the hard drive. In the case of an IDE controller, not only the master and slave positions, as on small pins, but also the connector location must be. The first connector is the primary, the second is the secondary. Depending on the type, their speed is 3600 to 7200 RPM. And their data transfer rate ranges from 900 kbps to 1 to 2 Mbps. Their access time is 8 to 15 milliseconds. Their capacity is very different, they used to be 300 MB, but the latest models can reach 20 to 30 GB. Newer IDE controllers are familiar with Ultra DMA, UDMA, standards, UDMA 33, UDMA 66, or UDMA 100. With direct memory access, the baud rate can reach 33 Mbps for UDMA 33, 66 Mbps for UDMA 66, and 100 Mbps for UDMA 100. The baud rate of the Winchester itself is not affected by UDMA. This, of course, requires a hard disk that knows the standards. UDMA 100 interface with the same pole, but larger shielded cable. SCSI hard drives are becoming more common. They used to be 5.25 inches in size, but today they only make 3.5 inches. They communicate with the motherboard via an ISA or PCI SCSI bus card. SCSI 8-bit cards have a 50-pin connector. SCSI mode. Some cards also include an 80-pin connector with all the necessary signals. The SCSI and SCSI 2 controllers can handle a total of 7, and the latest SCSI SCSI hard drives are capable of data transfer rates of up to 5 Mbps. When using the SCSI 2 standard with fast SCSI mode, a data rate of 40 Mbps is available along with 10 Mbps or wide SCSI mode, which provides a 16-bit or 32-bit connection. Drives cannot take advantage of these theoretical values, EPS. Hard disks receive their own disk identification signal, letter ID, in the order of their configuration and logical partition. The disks are A and B, the hard disks, and the drives that can be replaced are C, D, E, F, and digital magnetic signal recording. Original sign. Magnetization. NRZI sign recording mode. The physical structure of a hard drive. Disks and their two sides. Tracks. Directory structure. Top is the main folder. Under is the first folder, the second folder and the third folder. During these